What is up guys, this is Luke Hill for KitGuru, and in this one we're going to be taking a look at the Asrock Z490 Phantom Gaming ITX TB3 motherboard. Now we know this is Z490, so it has been out for a while, but this is still Asrock's highest end ITX offering for the LGA 1200 platform, and presumably through a BIOS update coming in the future weeks, this will be Intel 11th gen compatible, so still a high-end offering. Still a valid offering on the market. Looks like a good motherboard on the front of it. £290 in the UK, but spoiler alert, it's got some pretty glaring weaknesses and downfalls. So yeah, view on to find out just what we mean. You might be quite surprised at some of the findings. Before we jump more deeply into the board though, if you like what we do here at KitGuru, make sure you give us a like and subscribe on the YouTube channel, that really helps us out. Check out the KitGuru website where you can see the written information on the page, that really helps us out too. And you can support us through Patreon or through our merch store. Let's get back into it. If we start off with a general overview of this £290 Z490 Phantom Gaming ITX TB3 motherboard from Asrock, it looks premium, it feels premium, it's well built, it's sturdy, got these large heat sinks, primarily black, so it's got a nice dark black PCB. I quite like the colour scheme personally. And then when we look at the connector positioning, you've got your 8-pin nestled away in a logical location, 24-pin is in a sensible region, you've got a couple of 4-pin fan headers for the CPU, and then one more for the system fan header, so you get 3 in total. That's pretty reasonable. You've got 2 RGB headers, which is quite common for ITX motherboards, and then a couple of outwards facing SATA ports. All looks pretty good thus far. But to be perfectly frank, the positivity that we've started out with weighs pretty thin, and the points start to go downhill quite noticeably from here on outwards. If we start by taking another closer look at some of the hardware on the motherboard, then one of the initial points you'll notice is that there's no internal USB-C header. This is incredibly disappointing for a high-end, almost £300 motherboard. If we jump along to the riser card, you can see another 2 SATA ports, an internal USB 2 header, and a speaker header. Now initially this looks like a pretty good solution because you free up some valuable PCB space on your mini ITX motherboard. And of course when you're installing your M.2 SSD, you don't need to dismantle the entire system to get round to the other slot that we see on the back of the board. So this looks like a good solution. But when you dig deeper and you look at it a bit more closely, you realise some fundamental flaws of this implementation from Asrock. Firstly, the riser card sits about 2 centimeters above the rest of the hardware on the motherboard. And this is all pretty critical, because if you start going above this height, then you are starting to cause interference with certain cases that are quite short, or with riser cards, for example, with other components in the system, perhaps CPU coolers. Of course, if you do have the clearance to install the cables like you want to in the vertical orientation, then the challenge there is that you'll have a graphics card likely underneath, and you're going to be trailing ugly cables across the back side of your perhaps good looking, perhaps good backplate graphics card, so not ideal from a cable management perspective. Basically this riser card, in my opinion, looks like a pretty good solution on paper, but in practice really not ideal with some glaring caveats. It does, however, have 4 post debug LEDs which are clearly visible, and that's a really good troubleshooting feature in all fairness. Jumping around to the rear I/O, the star of the show here is clearly the Titan Ridge powered Thunderbolt 3 Type-C port. Internet comes from the 2.5 gigabit Realtek controller, and this is good to see because it's not the troublesome Intel controller that's having firmware issues. And display outputs are another positive for the Asrock motherboard. You get DisplayPort 1.4, HDMI 2.0, and of course Thunderbolt 3, which carries DisplayPort over the Type-C connection. And this is where the rear I/O starts to get a little bit confusing. So you've got a clear CMOS button, that's absolutely fantastic, really good to see. However, it's really disappointing to see the complete lack of BIOS flashback capability through a USB port and a button. And this is really disappointing because you have to install a compatible CPU to update the BIOS on this motherboard. You can't do it with just a power supply connected like some competing boards. Now, I can understand the lack of BIOS flashback capability on a cheap budget motherboard, but on an almost £300 premium high-end offering, that's really not good. Does anybody really use PS2 compared to the functional usefulness of a BIOS flashback capability? I'd argue that BIOS flashback is more important than this port. Now let's focus on the VRM solution, and as you've probably guessed at this point, this is quite frankly another mixed bag. The core VRM components are really good. You get a 9-phase solution. You get 6 phases of Intersil ISL 99390 90 amp power stages dedicated for the CPU vCore, and then you get 2+1 of Intersil ISL 99227 60 amp power stages for the ancillary voltage rails. So that's a fundamentally really powerful solution, especially when you combine it with the Intersil 69269 PWM controller, which can handle all of these 9 phases without any doubling. Excellent solution in terms of electronic hardware. Where the system quickly starts to disappoint though is in regards to the VRM cooling. Now, let's just focus first on this top VRM heatsink, which is fundamentally just a really quite small slab of metal that is isolated on its own because it's not connected to anything via heat pipe. It's an awkward shape with regards to interference, but more on that later. And Asrock does make some, quite frankly, minimal effort to fin this heatsink, but instead they basically just slap a 30mm fan on the backside, which eats into so much of the heatsink space that the metal itself doesn't really account for all that much mass or all that much surface area. Really not a good design. And then when we look at the rear I/O side heatsink, this is better, but not all that much better, quite frankly. The heat pipe bridges out to the chipset heatsink. Not really sure why that's even done, quite frankly. The heat pipe should be coming to link the VRM heatsinks, really not that important chipset heatsink, but whatever, I guess. And again, we've got a 30mm fan blowing down towards the motherboard, which eats up a considerable chunk of the fin array, so not ideal. The fans themselves are controlled via a single header, and at full speed, the registered RPM was 11,000 RPM, which I must add is very, very audible. Thankfully, Asrock gives you some pretty decent predefined fan curves and some pretty decent fan control capability for the VRM fans, but that really doesn't change the fact that they're 30mm fans with a hub to blade ratio that is significant in the favour of the hub, so they're not really going to do all that much, quite frankly. And I must say that I know a fan of some sort on an ITX motherboard these days, whether it's AMD or Intel, is very common, but 2 fans just for the VRM seems rather excessive in my opinion. Just design a good heatsink. Oh yeah, and one other factor that's pretty disappointing about the VRM cooling is that this top fan, which is critically important given the small size of the heatsink, actually blows in a top to bottom orientation. So it goes quite directly against an all-in-one liquid cooler that might be mounted above it, which is going to be pulling air from bottom to top. It's going to have to fight against a 2x120 or a 2x140 CPU AO liquid cooler. It's got absolutely no chance. I don't know why Asrock is going against the conventional airflow path, probably because they've just lumped the fan on the backside. Not a great design, but we'll have to wait and see how the performance manages in our testing. And then with respect to capacitors, you get a bank of 470 microfarad flat capacitors on the rear side, and then a bank of normal 12K rated capacitors on the front side, although these are pretty close to the CPU sockets. You will have to be careful for interference with CPU coolers or CPU cooler mounting brackets. Speaking of cooler interference, it's incredibly obvious to see the glaring issues that we're going to face with any reasonably sized CPU cooler, quite frankly. You've got a really tall topside VRM heatsink, a tall and quite bulky and protruding rear I/O side heatsink. You've got an oversized chipset heatsink, and then you've got this tall riser card. Quite frankly, it's a bit of a minefield when it comes to picking a CPU cooler that is not going to interfere with at least something here. And we say this from experience. We spoke to James, who's done a handful of builds with this motherboard, and he highlighted how he basically went through a stack of CPU coolers and found quite a few that didn't fit. Quite a few common popular coolers that didn't fit. So there are a few Be Quiet, Dark Rock, Tower style units that just simply wouldn't fit. He actually found some all-in-one liquid coolers that wouldn't fit because of the block and the bracket mounting, and that's really quite disappointing. It's very rare to get an all-in-one liquid cooler that doesn't fit because of your CPU socket and VRM heatsink proximity. We can, however, say that we used a Fractal Celsius S28 Plus Acertec design CPU cooler, and this is one of the smaller pump block units, according to James. He's our cooling expert. So that did fit. It was a tight fit on the rear side with regards to the bracket for the cooler because it butted up quite close to the rear M.2 slot, especially if you've got an M.2 with a heatsink on there, but it did just about fit. Basically what we're saying here is you have to be really careful with your choice of CPU cooler because Asrock has kind of given you a bit of a cramped space to work with. Anyway, I think that's enough for the motherboard overview. Let's jump into some testing to see how the Asrock Z490 Phantom Gaming ITX TV3 behaves. Starting off with the UEFI, we think Asrock does a pretty good job overall. The layout's clean, straightforward to navigate, and it has a good, easy mode. There are some areas where I'd like improvement. For example, 1.5 volts is obviously high for the CPU V-core, but it doesn't change to red and warning until about 1.55 plus volts, so this could be changed. And the fan control is okay, but it does need to improve to tackle the capacitors. You get good multi-point fan curve abilities and the predefined settings are a positive, but there's no hysteresis control for managing the rate of change of fan speed, which is particularly important for day-to-day system usage. And the ability to control fan speeds and curves based on multiple temperature inputs is basically lacking. One other good point about the UEFI though is the sheer quantity of user save profiles that Asrock gives you. A strong positive there. If we now focus on performance, check out the KitGuru website for details on our test system. Basically, we're using a Core i9-10900K CPU. We use a Fractal 280mm Acertec liquid cooler. We've got a 3600 MHz 2x16GB kit of Corsair Vengeance LPX DDR4, and we're using a Seasonic 1 kilowatt power supply and a Gigabyte RTX 3080 Eagle OC graphics card. Performance numbers from the likes of Cinebench are fine and are competitive against alternative Z490 offerings with our Core i9-10900K at stock settings. In terms of multi-threaded performance, the Asrock board handles our initial quick benchmarks pretty fine. The same can be said for memory performance, which is perfectly good with the Corsair Vengeance 3600 MHz kit, and XMP works fine out of the box with regards to memory speed. We were also happy with the speeds of the Thunderbolt 3 port when using our external SSD. We saw the typical speeds that we tend to see from competing Thunderbolt 3 motherboards. And Asrock's front-side cooling solution on the riser card also proved solid for our WD Black SN850 test SSD when constricted to PCIe Gen 3 by 4 speeds. If we now focus on temperatures and power, we saw some readings from the motherboard that really give us a bit of concern actually. So Asrock's stock voltage and power settings for the Core i9-10900K are particularly aggressive. There's some of the more aggressive performance settings that we've seen. We registered a wall system power draw of close to 400 watts and a Cinebench and Blender CPU only load-in, and that's really high. That's about 100 watts higher than we've seen from the likes of Asus, Gigabyte and MSI competing Z490 motherboards that both myself and Leo have tested. The CPU package power was actually in excess of 250 watts according to our load figures under stock XMP settings. Asrock's stock XMP settings are, put simply, terrible. So much so that the temperatures we saw from the chip itself were actually CPU cooler busting. I mean, even our 280mm Acertec designed AIO was struggling to keep below 99 degrees Celsius under reasonable time periods of Cinebench and Blender loading. That's really not good for a stock configuration, and when you combine that with a tight, small form factor build that's going to be running like a hot box, not ideal. Absolutely not ideal. Poor settings out of the box. More concerning though is the effect that shifting such high volumes of power through the VRM has on MOSFET temperatures and the readings that we saw in HWinfo and the likes. And what you will see up here is the VR Loop 1 sensor is registering at about 104 degrees. It spends a little bit of time there and then it throttles the power, and it throttles down to about 80 watts instead of about 230 watts for the VR power output. So if we just keep an eye on this one that says motherboard VR thermal throttling, you'll notice with a 100 millisecond polling period for XTU, it flashes on or off. And when this flashes yellow, keep an eye on the package TDP. So that drops down significantly, which implies that it is causing a throttle. And when you keep an eye on that, and keep an eye on the max core frequency. So when it throttles down, you'll typically see, there you go, so you'll lose over 8 gigahertz on the core frequency. And just in case you thought, as we did, that this might just be some software readings or some quick flashes that we're seeing in software but are not really effective in the real world, keep an eye on the physical power meter. So you'll see that it drops. So at full speed, it's running about just under 400 watts, and it does drop quite significantly. So you can get 260 watts. We've seen drops down to about in the order of 200 watts, but you are shutting off quite heavily in regards to VR throttling. Not ideal. Despite using really high-end Intersil components, the subpar heat sinks for VRM cooling result in very high temperature readings according to the software sensors. When we see one of the sensors quickly rising to over 100 degrees Celsius and actually registering 104 or 105 degrees Celsius, that is real cause for concern. Now yes, the components can probably handle that temperature, but we did notice power throttling for the CPU because of the VRM temperatures and the stock configuration. Yeah, that's right, this £300 premium Z490 ITX offering strapped with a 280mm liquid cooler on the Core i9 10900K, actually VRM throttled under stock conditions. That's really not good. Our overclocking test actually managed to reduce the temperatures thanks to better voltage selection despite the higher frequency. So here you can see that our overclocked voltage is 1.325 volts, and that's using level 1 load line calibration. And we run at 5.1 gigahertz frequency. So actually we're getting better performance from the motherboard and from the system, and we're getting lower power consumption numbers as compared to Asrock's stock settings at 4.9 gigahertz all-core. 200 megahertz higher operating frequency for lower power draw. That shows you just how bad the stock settings really are. Even with this reduced thermal load though, the VRM still showed very high temperature readings in addition to signs of thermal throttling clock drops, albeit less frequently than the badly tuned stock configuration. We did wonder whether these issues were actually tied to the VRM fan simply not spinning up fast enough under load conditions, even though it was handling at about 6 to 6,500 RPM with those 100 plus degree temperature readings. So we basically tuned the fan to its maximum of about 11,000 RPM according to the sensor reading, and it didn't really make all that much difference, quite frankly. We still saw the same throttling behavior occur. The cooling design is actually inefficient to the point where dealing with the obnoxious VRM fan noise at high speeds is simply not worth it given the barely useful change in cooling performance. If we summarise this review then for the Asrock Z490 Phantom Gaming ITX TB3, we'd say that Asrock has taken what basically looks to be a solid selection of hardware and created what looks to be a fundamentally solid motherboard. But when you dig deeper and start using the motherboard in a real ITX situation and with a high-end CPU, the weaknesses of Asrock's design choices are glaringly obvious. A technically excellent VRM solution with high-end intersil components is let down by poor heatsink design and 30mm fans that look to be barely worthwhile. And the riser card is a great idea in theory and on paper, but it causes interference headaches and cable management challenges in practice. Plus the lack of a USB Type-C header is really disappointing on a motherboard of this caliber. There's no excuse for that as far as I'm concerned. It's even worse than the lack of BIOS flashback functionality, which I'd argue that not everybody needs. Internal USB Type-C header, it's an absolute must on a £290 premium motherboard these days. And of course, if you can look past the questionable header choice, the limited VRM cooling and the physically awkward riser card, then your concerns are actually not simply alleviated at that point. And that's because you then have to plan your CPU cooler choice wisely to get around the physically awkward proximity to the LGA 1200 CPU socket. If we close out then, I'd say it's perfectly reasonable to highlight that some of these concerns we've highlighted may not affect you, and that's perfectly fine. Maybe you have a roomy ITX chassis, a moderately overclocked CPU, and a cooler that fits absolutely fine. In that case, you're good to go. Or maybe you don't care about USB BIOS flashback functionality because you've got a 10th gen CPU and you're just going to leave it at that. Or maybe you don't simply plan to use the headers that are going to sprawl across the backside of your graphics card, so you're not worried about the cable management headaches they will cause. And they're all perfectly fine points which may make this board suitable for you, especially with that Thunderbolt 3 port, the strong rear I/O, and the straightforward and easy to use UEFI. However, that doesn't butter over the fact that there are clear weaknesses with the Asrock Z490 Phantom Gaming ITX TB3 motherboard, and I'd actually recommend looking at some of the competing offerings if you are looking for an 11th or 10th gen Intel Mini ITX offering. Not a great implementation by Asrock. You could see that some of the intent was there to make a really high-end premium offering, but the actual deployment is subpar. Hopefully they can fix this going forward, because this is not a great effort in my opinion. But of course, if you disagree with me, if you have this board and you use it and you like it, let us know in the comment section down below. I've been Luke Hill for KitGuru. Thank you for watching this video review of the Asrock Z490 Phantom Gaming ITX TB3 motherboard. Let us know what you think in the comment section down below. Would you be concerned seeing VRM sensor temperatures registering over 100 degrees Celsius? Would these pair of little fans annoy you? Or do you just stick headphones on and just deal with it? And would the riser card be awkward with regards to your CPU cooler, or are you just going to stick a small aero on there? Let us know in the comment section down below. Really keen to hear your thoughts. If you like this video, give us a like. hit the subscribe button, support us on YouTube, follow us on Vimeo. Head on over to the KitGuru website where you can see the written page with all the details, and that really helps us out. And make sure you support us through Patreon if you can, or by buying a cool t-shirt like this through our merch store. Catch you in the next one.